Alright, so what I'm going to do now is I'm going to work a KSP problem. The only time it really appears is in number 1. The equilibrium problem can be a KSP problem. Very rare, but I figured what the heck, it's Sunday, why not? You guys are studying. If you have trouble with KSP, I'll go through this. You should understand a little bit better. All number 1s start with the equilibrium constant, so that's the first thing you got to do. Remember, we don't include solids in an equilibrium expression, therefore it's just going to be these two on the top, and we use the coefficients to represent the exponents. So what you would end up with is KSP is equal to PB to the first, I minus to the second. If you look at the next thing in the problem, they'll usually tell you, they'll either give you grams and liters and tell you an ion so you can find a concentration of an ion, or the molarity, which is the same thing as S. Or in this case, they actually told you what the molarity of Pb2 plus is. Now remember, when this breaks apart, if you look right here, it breaks apart in a 1 to 2 ratio. So what does that look like if you did a mini ice table? Well, it would look like this. It would be Pb I2 as a solid breaks into Pb2 plus I minus 2I minus. So this is going to be S on the E line and 2S, right? So if we drop all the way down to the E line, we have this. So when they tell me the concentration of PB, they're telling me S. Remember, before I go to my expression, do my calculations, I need to get my values on the E line. They're independent of each other, which means you take the S, find the values on the E line, then you take them. I take those values, and they get put into the expression. So first write the expression, figure out the ion concentration, then plug them back in. So if they tell me the ion concentration is 1.3 times 10 to the negative third, and I know that's S from the E line, in order to get I minus, I must double it. So I take that value and multiply by 2, and that's what you see them do right there. I take 2 times 1.3 times 10 to the negative third. I get a value of 2.6 times 10 to the negative third. So that's my value for this. We already have the S value. Then I take them and plug them into the expression. What does that look like? Well, there's the 1.3 times 10 to the negative third that was given me in the problem. There's the I minus that I doubled. They go right into the expression, and I also square them. First find the E line values, then take them and put them in the expression. KSP in this case, KSP is going to be equal to 4S cubed. But they still want you to find, if you take basically 1.3 times 10 to the negative third, and you did this to it on your calculator, you would get the same answer. But they're asking you to figure out the ratio of I minus here. Well, I made a mess of that, didn't I? They're asking you to find the ratio of I minus right there. So if you look right here, right there, they want the I minus, which that's the E line. All right. Next thing, actually, that's pretty easy. These are unusual. Typically, they'll just pretty much have you do those. One of the questions they ask is, why, if you dilute it to 2 liters, will it not change? What will happen to the molar concentrations? Well, the moles are in there no matter what. So the number of moles isn't going to change even if you dilute it any farther, because solubility is not related to volume. Okay, it's related to the type of reactants that we have. The next thing they ask you is, well, what happens if I add I minus? Because really, NaI has a common ion. That's how you have to approach it. So if you look like this, PbI2 arrow, I get Pb2 plus 2I minus. If I'm adding I minus, remember, if I'm adding according to Le Chatelier, add shifts away. If I shift this direction, the concentration of this is going to go down. So it's an application of Le Chatelier's principle, stating that if you add something, a common ion, look on the right-hand side of the equation. That's where the Na, because NaI breaks into Na plus, I minus. It's a Le Chatelier's problem. And it's going to shift it to this direction, which basically you would explain using, here's the explanation that they gave. If you look right here, that's not the right explanation. If I look right here, let's see here. Well, where is that question? Did I delete it? I guess I did. I guess I deleted it. Anyway. Next question asks you, will a precipitate form? Remember, the first thing you have to identify is what is the precipitate. They're telling you in this problem. Sometimes they don't tell you using solubility rules. But if I combine barium nitrate and NaCr2, using the same rules we use for our equation, sodium's always soluble and so is nitrate. So really what we're talking about is we're talking about forming Ba 2 plus is going to come together with CrO4 2 minus and produce BaCrO4. It's a solid. First thing you have to do is find moles of each. That's the first thing. You calculate the molarities of each, plug them into the, actually I should have wrote it the other way. The KSP for this thing is going to be, I should have wrote the equation the other way, is going to be the concentration of Ba2 plus, concentration of CrO4 2 minus. Imagine this is flipped around. I don't know why I wrote it that way. Anyway, so the first step is find the ion concentration. How do you do that? Well, you take 500 milliliters, which is going to be 0.5, times the number of moles, or molarity actually, sorry, 8.2 times 10 to the negative 6. I multiply that. So when I multiply the liters 0.5 times the molarity, I get 4.1 times 10 to the negative 6. What's my new volume going to be? Well, I have 500 plus 500. They're making it easy. It's going to be 1 liter, so that's going to be the same as the molarity. Imagine for the other one, 8.2, they made these the same. 0.5, you'd still do it the same process though. Liters times molarity, 8.21. This is easier than normal. 10 to the negative 6. Liters times molarity gets me moles. 4.1 times 10 to the negative 6th. And then I divide by the new volume. The whole point is you take the moles by taking molarity times liters, get moles, and divide by the new volume. And then you take those new volumes, or those new molarities actually, when you divide by the new volumes, and you plug them into the expression. I would plug in one here and one here. In this case, this breaks into 2 ions, so it's really just S squared. So to figure out the Q, or calculate the Q for this, all I have to do is take 4.1 times 10 to the negative 6, since they're the same value here, and square them, and I get my Q value. Because if I plug in numbers, the Q and KSP expression is the same thing, and I compare them. They told me the KSP value is 1.2 times 10 to the negative 2nd. So if you look, when I plug in 4.1 times 10 to the negative 6, 4.1 times 10 to the negative 6 into the expression, same as the KSP expression, I get 1.7 times 10 to the negative 11th. Since Q, 10 to the negative 11th, is smaller than 1.2 times 10 to the negative 10th, we say no precipitate forms. For in order for a precipitate to form, Q has to be greater. If Q is greater, we've gone past SeaWorld, which means the reaction will shift back to the reverse. That's why I kind of wrote it wrong at the beginning, which is barium chromate, which is here as a solid, which would be Ba, that's supposed to be an arrow, Ba2 plus CrO4 2 minus. Wow, that's bad writing. But that's the key. If Q is greater, Q is larger, it's going to shift this way. In this case, Q is smaller, and that's why we say no precipitate does not form. They told you that in the problem. You just had to actually sit and apply it. That was what it came down to. So basically, that's how a KSP problem is done. Key things to remember when you're doing a KSP problem: write the expression. They're going to ask you to figure out one of the ions. Remember, whichever ion they give you, or if they have you calculate molarity, what drives it is the ratio between them. This was a 1:2 ratio. Therefore, they gave me the value of lead. So in that case, I had to double it to get the other one. Had they given me the I minus value, let's say they told me the value of I minus, I would have to divide it to get the PB or the S value and plug it in. KSP is just plugging in the expression. They'll have you find an ion concentration, and then they will typically have you find whether or not a precipitate forms. 3 easy steps: find the moles, put the new volume underneath, plug it back into the expression. That's all you have to do a KSP problem. All right? Same thing in the multiple choice section. You don't have a calculator, so it's important to know the shortcuts. In case you don't know the shortcuts, really quick, I'll go over them really quick. They're on the little gangster's guide sheet I handed out. But for example, if you have 2 ions, if you break into 2 ions, like for example, AgCl, your KSP value is going to be equal to S squared. If you had 3 ions, which would be like Mg parentheses OH parentheses 2, your value would be 4S cubed. The last one would be, well, not, there's 2 other ones, but those are the ones that are most common in the free response section. They're not going to get too crazy. The other shortcut is 27s to the fourth. That's if you break into 4 ions. So remember here, then you just remember 4 ions, 3 ions, 2 ions, and then the number goes 1, 4, 27. This is 4 ions. That would be like aluminum hydroxide here. This is insoluble, right? You get 3 ions here, 1 ion there. All right? Have a good evening. Good luck on the exam.